Okay, guys, here's the back of your 6.3 day one notes. Just finishing up the range of the cotangent function and the range of the cosecant function. Well, remember, if I ask you, they're going to be very similar to the tangent and the cosecant. The secant, I should say. All right. If I asked you, what's the range of the cotangent function? Well, think about how that function works. Angle goes in and the cotangent ratio comes out. Well, the cotangent ratio used to be A over O, right? Because it's the reciprocal of tangent. But now on the coordinate plane, it's a x coordinate over a y coordinate. Well, remember, in terms of a right triangle or an x and a y coordinate, there's no rhyme or reason to A being bigger than O, or O being bigger than A, or X being bigger than Y, or Y being bigger than X. There's no rhyme or reason to which one's bigger. So you might have X is bigger than Y. So then you have a big number divided by a small number. So that's going to be an answer that's bigger than 1. But maybe X is smaller than Y. So then you have a small number divided by a big number. If that's the case, the answer is going to be less than 1. So since there's no rhyme or reason to whether X has to be bigger than Y or Y has to be bigger than X, that just means that the ratios that this function spits out could be any number. It could be all real numbers. Numbers bigger than 1, numbers smaller than 1, right? All right, so his domain is all real numbers. All real ratios can come out. Okay, well, what's the range of the cosecant function? Well, think about how the cosecant function works. An angle goes in, as long as it's an angle in his domain, an angle goes in and a ratio comes out. It used to be the ratio of H over O, right? Because it's the reciprocal of sine. But then we got redefined, so now it's a radius over a y coordinate. Well, if you think about it, H was always bigger than the opposite side. The radius is always going to be the biggest side compared to any y coordinate. So it's always going to be a big number divided by a small number. And what's a big number divided by a small number always going to be? It's always going to be greater than 1. Or if we're thinking about negative ratios, that'll always divide to a number that is less than -1, to the left of -1. So the range of all of these ratios are numbers that are bigger than 1 or less than -1. So the y values that live on his graph, the ratios that come out, it will either be a number bigger than 1 or it'll be a number smaller than -1. So his ratio will be, in interval notation, -infinity to -1, union 1 to infinity. Okay? All right, perfect. Well, now we kind of got to talk about the periods again, but remember, I already explained the periods to you in the other video from before, the first video you watched. Just remember, a periodic function are functions whose outputs start to repeat themselves after a certain number of inputs. The amount of time that it takes for those those outputs to repeat is its period. So the 6 trigonometric functions are periodic functions. After so many units, they start to repeat themselves. The number of units it takes to repeat themselves is called their period. So we saw yesterday, or I shouldn't say yesterday, the video before that I did this one, that the period of sine, cosine, cosecant, and secant, all of them take one complete rotation around the unit circle for the outputs to start repeating. So they all had a period of 2 pi radians, one complete rotation. All right, an angle had to be a complete rotation away from him for the output to start repeating. But the tangent and the cotangent, remember, they started repeating their outputs quicker. That was every pi radians they started repeating. So they had a period of pi. And again, I explained that in the other video that you should have watched first. Okay, so those are their periods. So basically what that's saying is that the sine of angle theta will equal the sine of that angle theta plus any angle that is 2 pi radians away from him. They'll have the exact same sine ratio. All right, the cosine of angle theta will equal the cosine of theta plus 2 pi radians, anything that's 2 pi radians away from him. And even minus, you could go the other way. Plus or minus works as well. All right, the tangent of angle theta will equal the tangent of any angle plus pi radians. Any angle that is pi radians away from him will have the exact same tangent ratio. All right, the cosecant of angle theta will equal the cosecant of theta plus 2 pi radians away. Any angle that is 2 pi radians away from that angle will have the exact same cosecant ratio. All right, and then the secant of angle theta will be equal to the secant of theta plus his period 2 pi. Any angle that lands in the same spot as theta will have the exact same ratio. And then cotangent of angle theta will equal the cotangent of theta plus pi radians. Any angle that is pi radians away from theta will have the exact same cotangent ratio. All right, that's just their period. So the important thing is to remember that these ones all have a period of 2 pi, one complete rotation. These two have a period of pi, only half a rotation, and the outputs start to repeat. All right, then they just ask you to find these special exact values again. So this should feel like exactly what we were doing in 6.2. Figure out where the angle lands and get me that ratio. All right, so what's the sine of 390 degrees? Well, where does 390 degrees land? Obviously, he's bigger than one rotation, right? So I'm gonna go all the way around. There's 360 degrees. I gotta go 30 more degrees to get to 390. So when I'm taking the sine of 390 degrees, he lands in the same spot as 30. So that means that I'm taking really the sine of the reference angle, the sine of 30 degrees, and it landed in quadrant 1. And then what is the sine of a 30? Well, look at your special right triangles or go look at your unit circle. What's the y coordinate at 30 degrees? It's 1/2. And because we're in quadrant 1, that should be a positive ratio. All trig functions get you a positive ratio for angles in quadrant 1. All students take calculus. So the answer is 1/2. All right, what's the tangent of 13 pi over 6? Well, where does 13 pi over 6 land? Well, guys, let's get our anchors. We got pi is halfway around, and we got 2 pi is all the way around, right? Well, then in the worlds of pi over 6, what do we got? This is 6 pi's over 6, and then that's 12 pi over 6. So if I'm 13 pi over 6, my 13th 30-degree angle, that means I have gone all the way around to 12 pi's over 6, and I got to go one more pi over 6 to get to 13 pi over 6. So the tangent of 13 pi over 6 is really, what's the reference angle? Pi over 6. It's really asking you to take the tangent of pi over 6, but you landed in quadrant 1. Well, what is the tangent of pi over 6? What's the tangent of a 30-degree angle? Go look at your unit circle or go look at your special right triangle. The tangent of a 30 is root 3 over 3. And since we're in quadrant 1, the ratio is positive. All students take calculus. That's a positive ratio for an angle that landed in quadrant 1. All right, what's the sine of 17 pi's over 4? Where do 17 pi's over 4 land? Well, think about it. We got pi radians here, and we got 2 pi radians there. So let's get our anchors. We're dealing with pi's over 4. So this is 4 pi over 4, and this is 8 pi over 4. So if I go all the way around, I've gone 8 pi's over 4. I need 17. So if I go 4 more, that puts me at 8 pi over 4, that's 12 pi's over 4. All right, if I go 4 more, that's going to be 16 pi's over 4, bring me to there. I'm trying to get 17. So if this is where 16 pi's over 4 land, that 17th is going to be right there. That is 17 pi's over 4. So what's your reference angle? Pi over 4. So what you're really doing is taking the sine of pi over 4, and it landed in quadrant 1. So what's the sine of a 45-degree angle? Go look at your circle or go look at your special right triangles that you can draw. It's root 2 over 2. And since I landed in quadrant 1, what sign is that ratio, positive or negative? It's positive, because all trig ratios are positive for angles that land in quadrant 1. Okay, all right. What's the cosine of 5 pi? Well, where does 5 pi's land? Well, this one shouldn't be that bad. Think about it. That's 0, and here's 180. This is pi. So that's 1 pi. And then I go another, that's 2 pi. And then I go another halfway around, that's 3 pi. Oops, sorry. Then I go another halfway around, that's 4 pi. Then I go another halfway around, that's 5 pi. So 5 pi radians lands in the exact same spot as pi. And what ordered pair lives there at pi radians? That's 1 to the left. That's the ordered pair -1, 0. So what's the cosine at 5 pi? What's the x-coordinate? -1. The answer is -1. That's your ratio. All right. What's the tangent of 19 pi's over 4? Where do 19 pi's over 4 land? Let's get our anchors. All right. Well, we got halfway around is 180 or pi radians, and then all the way around is 360 or 2 pi radians. In the worlds of pi over 4, though, this is what? 4 pi's over 4, and then that's 8 pi's over 4. So every 4 pi's over 4 gets me halfway around. Where are 19 pi's over 4 going to be? So here's 4 pi over 4. 8 pi over 4 gets me all the way around. We'll keep going. 4 more gets me to 12 pi's over 4. Okay, I'm getting 19. So I go another halfway around. That's 4 more pi's over 4. This is 16 pi's over 4. So I got to keep going. If I go another halfway around, I would get all the way to 20 pi's over 4. So 20 pi's over 4 land right here in the same spot as pi. So if I only want 19, I can't go all the way to 20 pi's over 4. So that means that 19 pi's over 4 lands in the quadrant right before it. So really, what's your reference angle? 1 pi over 4. So you're really taking the tangent of pi over 4, but it landed in quadrant 2. Well, what is the tangent of pi over 4? Or what is the tangent of that angle in quadrant 2, which would be 135 degrees, or the same spot as it, I should say. The same spot as 135 on your unit circle. What is the tangent of 45 degrees? Well, go to your right triangle or go to your unit circle. It's supposed to be 1. It's a tangent ratio of 1. But you're in quadrant 2, so all students, that means that only the sine function gets you a positive ratio for an angle in quadrant 2. So that means that this ratio has to be negative, because I would be dealing with a negative x and a positive y. What's a positive y coordinate over a negative x coordinate? Negative. The ratio has to be negative for the tangent function for any angle in quadrant 2. And your answer is -1. Okay? All right. Again, we've kind of done that already, so that should feel familiar. And then last, this one is super easy, so don't let this one be harder than it needs to be, right? Finding the quadrant in which an angle lies, because that's half the battle, is just knowing where the angle lies, so I know if the ratio is going to be a positive or a negative ratio. So remember, we have that fun thing that helps us called All Students Take Calculus. All trig ratios are positive in quadrant 1. Only the sine ratio is positive for angles in quadrant 2. Only the tangent ratio is positive for angles in quadrant 3. And only the cosine ratio is positive for angles that land in quadrant 4. Because what are our x-coordinates? Positive x, positive y. Cosine is positive, sine is positive. All right, if I'm a point in quadrant 2, I'm a negative x, I'm a positive y. That means my cosine ratio is negative and my sine ratio is positive for angles in quadrant 2. All right, if I'm in quadrant 3, I'm a negative x coordinate and a negative y. So that means my cosine ratio is negative and my sine ratio is negative for angles that land in quadrant 3. If I'm in quadrant 4, then I have a positive x and a negative y. So my cosine ratio is positive, my sine ratio is negative for angles that land in quadrant 4. All right, so recall, points on the coordinate plane, points on the unit circle, such as x, y, that correspond to the angle theta, the x coordinate equals their cosine, okay, and their y coordinate represents their sine. Okay, so look what example 1 says. If the sine of angle theta is less than 0, so a negative number, if that ratio is negative, and the cosine of angle theta is less than 0, so his ratio is a number smaller than 0, so it's negative, name the quadrant in which the angle lies. Well, think about it. The sine is represented by the y-coordinate. So this is saying that the y-coordinate would be less than 0. So that means the y-coordinate would be a negative value. Okay? This one says the cosine is less than 0. So that means that the x-coordinate is less than 0. So that means the x-coordinate is a negative number. So you would have an ordered pair that is negative x and negative y. Well, guys, what quadrant would have a negative x-coordinate and a negative y-coordinate? A point or angle that landed in quadrant 3. So you must be an angle that lands in quadrant 3 if you have a negative sine ratio and a negative cosine ratio. You are an angle in quadrant 3. Okay? All right, well, look here. What if the sine of angle theta is less than 0 and the secant is greater than 0? Name the quadrant in which the angle lies. Well, guys, think about it. The sine of angle theta is represented by the y-coordinate. So that is saying that the y-coordinate would be less than 0. So that would be a negative y-coordinate. Okay? The secant is a number greater than 0. It has a ratio that is greater than 0. The secant is the reciprocal of cosine. So that would be the reciprocal of the x-coordinate. That would be 1 over the x-coordinate is greater than 0. Well, in order for 1 over the x-coordinate to be greater than 0, that means the x-coordinate had to be a positive number. So the x-coordinate has to be greater than 0. So that means your x is a positive. So what kind of ordered pair would you be if you had a positive x and a negative y? Where would that angle or point land if they had a positive x-coordinate and a negative y-coordinate? It would have to be a point or an angle that landed in quadrant 4. So that angle that they're talking about with this negative sine ratio and this positive secant ratio, it would have to have been an angle that landed in quadrant 4. Okay? All right, guys. That's 6.3 day 1. Good luck. Let me know if you have any questions.